In this video, we're going to look more at factors. So we've talked about factors before, and so if you'll remember, factors are really useful when we have categorical variables, and what happens is the levels of the categorical variable are stored as what are called factors. So on the back end, R is going to see these as numbers, but they represent different categories. And the reason that factors are really important is because factors have some really nice properties when we're working with categorical variables. And so in this video, we're going to take a little bit more of an in-depth look at factors. And in particular, what we're going to look at is what is called the 4cats package. And this is part of the tidyverse. So you can either call 4cats individually, just like we've seen with ggply or dply or any other ones that were part of the tidyverse, or we could just call the tidyverse, which is what we typically do. All right. So first, we're just going to look at how to create factors. And so usually what's going to happen is you're going to read in a data set that already has factors in it, so you won't have to do this. But understanding how to build a factor will help you understand how to manipulate factors. Or if you read in a data set and your variable is stored as strings, knowing how to create factors and make that conversion will help you convert a categorical variable currently stored as a string in your data set to a factor. All right, so to start out with, I'm going to create a vector to hold education for 10 subjects. And education takes a couple different levels here. So you'll notice we have high school graduate, we have elementary school education, some college, college graduate, graduate degree, and so on. And we do have some repeats in here. So we'll just assume that I had 10 subjects in my study, and here is the education for those 10 subjects. Now notice here what I've done is I've stored this as strings, and so if we look at the structure of education, we can see here that this is a character variable, and then for each of those 10 subjects we have a different element. So as always, if we wanted to call an individual piece, let's say I wanted to see what the level of education was for the 5th subject, I can see that that is graduate degree. All right, now we might want to sort our subjects based on what their education status is. So what I'm going to do in this line of code is run sort education. And so notice what happens for my 10 different subjects, it does sort it by education. So in other words, for example, all of the some colleges are grouped together. We see that here. And our college graduate, we only had one. They're up here at the top by themselves. So it is grouping them, reading from left to right. But we know that education has a natural ordering. So in other words, ideally what we would like is elementary school education. We would prefer that to come before high school graduate to come before some college, and so on. So in instances like this where there's a natural ordering to our categorical variables, this is where factors come in really handy. So let's see how we could convert this over to a factor and why that would be useful. So if we look at our education for our 10 subjects, notice that there are 10 different levels of this categorical variable. And they are elementary school education, high school graduate, some college, college graduate, and graduate degree. And again, there is that natural ordering. So the first thing I'm going to do is just create a vector, and I'm going to call it edu level. And essentially what this vector is going to do is it's only going to include each of the individual levels of my factor one time, and it's going to include them in their natural order. So you'll notice here I've got the vector created and I have these levels in order. Similar to this, let's say you were storing days of the week, depending if you want your week to start on Sunday or Monday, you could list these out as Monday, Tuesday, Wednesday, Thursday, Friday. You could do the same thing with months, anything that has a natural ordering. And all this is doing is we're going to use this to tell R, hey, these are the levels for my factor and this is the order they should be in. So now, to convert my vector that holds education for my 10 subjects to a factor, I'm going to use the factor function. So I'm going to set edu factor equal to, and I'm going to apply the factor function, and I'm going to give it two different pieces. First, I'm going to give it education, and so remember, education is the education for my 10 subjects. So you can think of this piece as being that variable from your data set. And the second piece, what this is going to do is this is going to define the levels for the factor. And they are listed in order. So this is going to tell R to go through, I want you to convert this over to a factor, and I want you to put the factors in this order. All right, so let's run these. Now we could call our object edu factor, and notice if we run this, it looks very similar to earlier when we called education. So let me actually, just for comparison, call education down below. Do it just by running the education piece. Okay. And so notice they look very similar, but there are some differences. Notice when education, which stores everything as a character vector, we do have everything in quotations, whereas when they're stored in factors, the quotations are no longer there. And again, this is because on the back end, R is actually going to store these as numbers. You'll also notice down at the bottom, for a factor, it's going to list the 5 levels. And so here we have those 5 levels, and you'll notice that these levels are specified in the order that we gave it based on edu level. Now, just like before with education, we could look at a couple different things. We could look at the structure of the factor. And notice it does tell us the edu factor is a factor with 5 levels. And again, it's going to tell us what those 5 different levels are. And then at the end, it actually gives us a summary here based on the factors, or the factor levels. So for example, it tells us that the first observation has level 2. And so if you'll remember, level 2 in this case, if we go back, up here to where we define education level, high school graduate is the second level, and notice that the first person is a high school graduate. So that's kind of a little summary it gives you there with the structure. We could sort edu factor, and notice now if we sort by edu factor, not only are the similar elements grouped together, but they're now grouped in the appropriate order. So we have that natural ordering that occurs with education level. And then the last thing that's useful for any factor is you might want to see what levels are present in a factor, and you can use what is called the levels function. So notice here edu factor has 5 different levels, and there they are in order. Now there are a couple words of caution here in terms of the conversion. So up here, when we defined our data education, we have to remember that one, R is case sensitive, and anything we do with conversion is going to be sensitive to misspellings. You know, if we don't spell it a certain way, R is not going to know what it is. It's going to see it as something different. So what I've done here is I've created a new education vector. And you'll notice if I look through here, notice for high school graduate, for elementary school education, I've put an extra L here. And then also if we look at, I believe it's college graduate, is capitalized where it was not before. So let's run this. And again, this is going to just create a new character vector for education. It just has the spelling errors and the capitalization error in it. Now I'm going to convert this vector over to a factor. So I'm going to call it edu factor spelling error 1. I'm going to use the factor function to make the conversion. I'm going to convert that character vector we just created, and I'm going to use the levels that we specified before. So we're going to run this. And then let's look at the object. So notice what happened. Our 4th element, which was college graduate, and remember we had that capitalization incorrect. So when I specify the levels, it was specified with a lowercase g. Here we have an uppercase G. What happens is R, when it goes through to find those levels, it gets to this 4th observation and it can't find it because of the capitalization. So what it does in the factor conversion is it automatically changes it to an NA. Also, since elementary school education was spelled with 2 L's instead of 1, notice the exact same thing is going to happen on my 10th observation. So you do want to be very careful when you make that conversion over to factors, because you can lose data if you have things that are spelled different or you have different capitalizations. Now, one way to help you see that this is happening so that it's not masked is to use what's called the Parse Factor function. So notice here, I'm going to use the Parse Factor function similar to above, I'm going to give it the vector with the education level for the 10 subjects with the misspellings and use my levels. And notice if we run this, it is going to convert it over to a factor, but it's also going to give me some warnings. So notice it's going to tell me for row 4 and for row 10, and it's going to say, hey, I didn't know what to do with these. And again, it's because of the capitalization on graduate and the double L on school. So if you're worried about, potential misspellings or capitalizations, which happen often, in real data sets, using the parse factor is a better option because it will give you the warning if it was unable to identify which levels any of those characters should be converted over to. Right, so another thing that could happen is, well, what happens if we omit the levels? So here, I'm going to do exactly what we did before. I'm going to convert our regular education vector over to a factor, but notice I'm not going to give it the levels. So if we do this and we run it, that factor conversion is going to be done, but based on alphabetical order. So R is always going to default to alphabetical order, so that's why we do want to define the levels and give those, especially when there is a natural ordering for that factor. All right, so the next thing we're going to look at is what is called the General Social Survey example. This example does come from your textbook, so I highly recommend reading through this section. So the General Social Survey is a long-running U.S. survey conducted by independent research organization at the University of Chicago. So this data set, we can read this in. As always, you can read about it. And if we wanted to, we could also call the data set. This data set is stored as a tibble, so that's why we're only going to see the first 10 rows. Remember previously we saw how we could manipulate how much of a tibble we see, and we've talked about tibbles before. But looking through here, we can see that there are several different factors. We have race, we have an income variable, party ID, religion, and then denomination within religion, as well as number of hours of TV watched in a week. Right. So for any of these factors, we could look at the levels for those factors. And so we're going to look at 4 different options. There are probably other options out there. We could call the marital factor from the data set and then apply the levels function. So we can see that for the marital factor, there are 6 different levels. We could make a table of that factor, and again we get all 6, and then with the table we also get the counts for each of them. We could use the count function that we've seen before, and this is going to give us very similar to the table function, except it is going to place it into a tibble. And then we could also use a pipe operator. And notice the pipe operator does the same as using the count function. So just different ways that we could find those levels, especially when you have large data sets. Being able to find the levels for a factor are very important because those factors may not be, or probably the levels may not be explicitly given. Also, when you're reading in a data set that's automatically converted over to factors, what will happen is if you do have any misspellings, it will set those as different levels of the factor. And then if we wanted to do it visually, we could create a bar chart. And so here again we would see the 6 different levels with the counts. And this line of code right here for this particular factor doesn't do anything extra, but if you had a factor that had levels and some of those levels had 0 observations in the data set, what this would do on this scale x discrete is it would actually show all the levels, so it would even show bars that had counts of 0. Alright, so we can do some modifications with factors. So we may want to reorder the factor. So the first thing I'm going to do here is I'm going to use some pipe operators. So let's read through the pipe operator so if we can see what's going on here. So we're going to start out with our GSS data set. Then we're going to group it by marital. So we just saw that marital has 6 different levels, so this is going to create 6 different groups. Then for each of those groups in marital, we are going to use the summarize function, and what we're going to do is we are going to find the mean age for each of those groups. We're going to find the mean number of hours of television watched for each of those groups. And then we are going to find the total number of observations for each of those groups. All right, so we can run this. And now let's call the Tibble that we just created, that marital summary, and we get exactly what we thought we would for each of the levels of married or marital. We have the average age, average hour of television, and the number of observations of each of those groups. We could then go through and make a plot. So this is going to be a scatter plot, where what we're going to do is we are going to compare the average number of television watched per marital group. So if we run this, so here's our scatter plot. The problem with this scatter plot is to read it, there's not really a natural flow for our eyes. The points are kind of all over the place. Since marital is a categorical variable, what we could do is reorder our y-axis to make it easier to interpret this plot. So to do this, what we're going to do is use the function, and that should say marital. Your textbook does a very similar example with religion. So we're going to reorder this. So we have the exact same plot that we just looked at, but now these are ordered based on average number of hours of television watched in a week. And it makes interpreting the plot a lot easier, because now I can quickly look at this and I can see, okay, those that are widowed watch the most amount of hours of television on average, and then those who didn't reply to the marital variable watch the least, and we can go up through here. Again, same information as the plot before, but it makes it easier to interpret. Now, to do this ordering, we do need to be very careful, because we don't always want to do a reordering like this. And so let's look at another example. Suppose instead of marital status, we wanted to look at income. So here we have the exact same line of code that we had earlier, except we have income instead of marital status. So we start out with our data set, we then group by income status, and then for each of those groups we then find the average age, average hours of television, and the number in each of those groups. We can make a plot of these. So notice here we've done the reordering just like we did with the previous example, but the problem here is our categorical variable was ordinal. So over here on our y-axis, since the income is ordinal, these are now in all different orders, and it doesn't really make sense visually to do that. So do be careful. You have to make the distinction between whether or not your categorical variable is ordinal or not. If it's ordinal, you don't want to do this because you're going to mess up the order on the y-axis. But if it's not ordinal, like marital status, then it would make sense to do that, do an ordering based on average hours of television, because again, it would make it easier to interpret. So you do want to be careful in choosing, how you want to do the ordering and how you want to display the data. And then we have another example here of a type of reordering that's useful when you want to use colored lines on a plot. So again, we're going to use some pipe operators. We're going to start out with our data set. Then the next thing we're going to do is we are going to filter out. And what we're going to do is only keep those observations for which age is not missing, because remember the exclamation point means not. We are then going to use count to summarize by age and marital status. We are then going to group by age. And then what we're going to do is we are going to use mutate to find the proportions. So we can run this. And we could create a ggplot. So notice what we have here is for each of the different ages, we have the corresponding proportion. And then these are going to be the proportions in each of the different marital groups. Now, if we look here on the very right-hand side of the plot, we look at where the colored lines end. Notice blue's on the top, then we have purple, then we have that kind of lighter teal blue, and yellow and green. Our legend here is not in the same order, so visually, it makes it a little harder to match up. So what we could do is run this line of code, and that would order your legend. So what we can do is we look through here, we can look for each of the different age groups. So for example, for those at 40, if we look up, we can see that about a little over 50% of them are in the married group. Very few of them are in the widowed group. As we move up in age, we see that a much larger proportion is now in the widowed group. And I mean, that makes sense. As we think as people get older, one of the spouses is likely to die. But again, the idea here in ordering the legend is so that the legend is in order at what is occurring at the very end of the plot, again, just to make it easier for the reader. But the exact same information as the previous plot. And then finally, one last one we could look at is a bar plot where we do something very similar, but we could look at it in order of frequency for the bar plot. And again, you would only want to do something like this with a factor that is not ordinal. If the factor is ordinal, then you would want it, based on the actual order, natural order of that factor on the x-axis. Last thing we're going to do here is we're going to look at how we can modify factor levels. To do this, we are going to look at the party ID. So here, if we wanted to just look at a table of party ID for the data set, here are the different levels for party ID. And so we might want to change some of these to make them a little bit easier to read. So for example, we've got not strong Democrat and strong Democrat. It may make more sense to have Democrat be the leading piece in the description of the level, and then how strong they are in terms of being a Democrat to follow. And to do this, we will use a recode function. It's function recode. You've seen things like this before. Here we've got pipe operators and mutate. So what this is saying is we're going to start with our data set. We are then going to mutate the factor party ID, and we are going to recode it as follows. We're going to start with party ID. Our new levels are on the left. Our old levels are on the right. So Republican strong is going to be the same thing as strong Republican. And then finally, we are going to recreate the table of the new one that we did. Right. So you'll notice here, we have the same table that we do here, but now the leading part of the description is Republican, Independent, or Democratic, or Democrat rather, and then, the strength is what follows. And then very last thing, we can do something very similar to combine groups. So again, here, the new level will go here on the left, the old level is on the right. So you'll notice here on the bottom, we have 3 others in our new levels. And so we set them equal to no answer, don't know, and other party. And so these 3 will all get looped into other, or grouped into other. Now you do want to be careful when doing this to make sure that you don't lose any information that is important when you do this conversion. So anytime that you're grouping things together, always make a note that you have made that grouping and what that new group actually represents. So that is going to end the 12.1 video. As always, if you have any questions, please let me know.